Hello everyone. What we're going to be dealing with today is understanding what inverses are. Alright, so what we're going to do is, you guys have done parent functions. All the different parent functions that we're going to cover are right here. Okay, so you can look at your paper and start looking at your parent functions and go back to your journal and see if you can tell me which ones they are. This right here is a linear function. So what's this parent function? This is referred to as a linear function, and the equation that goes with it, I'm going to call it f of x equals x, also known as y equals x. Alright, so what we're going to do is we are simply going to look at our table. Now what I'd like you to do is make sure that you open Desmos as well. Alright, for some of these functions. Not all of them, but for some of them. Right now, let's just take a look at some points. We won't need Desmos for this one. Okay, it's pretty easy. You can kind of see right here. I'm basically going to go, if I go -2, -1, 0, 1, 2. If y is equal to x, then whatever x is, y is. -2, -1, 0, 1, and 2. Alright? Now, an inverse is when you take an x, y value and a y value, whatever it is. So sometimes you'll see it as a comma b, and you just invert them. So basically the new x value is y and the new y value is x. So you just swap them, so it becomes b comma a. Well, in a linear function, it really doesn't help. You really can't see the change, because if I take this one and move it, or if I take this one, it ends up being the same thing. So this is one of those weird functions where the inverse is itself. Well, it kind of makes sense. If this is y equals x, then we're going to say, we could also say what? X equals y. And when we graph it, we end up getting the exact same line that we had to begin with. That's not it. Let me make sure I go perfectly through here. I'll do a couple of rays and make a line. Probably makes it easier. So here we go. Let's go up 1 over 1, up 1 over 1 right there, and then there we go. That's a little bit better. Not great. Okay. So this inverse is itself. Now, is this a function or a relation? This is totally a function. Alright, it passes the vertical line test. Remember, a function has to pass the vertical line test, where no matter where you touch it going vertically, it only touches the graph once. Alright? Now let's go ahead and go down here and do another one here. Alright? So, this right here is a quadratic. And it's going to be f of x equals x squared, also known as y equals x squared. However, let me go to Desmos real quick, because I want you guys to see something. If I end up going to Desmos, and I type in y equals x squared, you can see it. The inverse would be x equals y squared. Interesting. So this is basically what we're going to be graphing. Now you'll notice here we can make a table out of this, because this is a function. So this is the table that we're going to be using to graph our function, y equals x squared. So we're just going to go here. We're going to put -2, -1, 0, 1, 2. -2 times -2 is right here at +4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So you can kind of see these points right here that I'm plotting. Right there. However, if I say, what's the inverse, I got to switch the points. So it's going to be 4 and -2, and 1 and -1. Now 0, 0, it's kind of hard to see that change, and 1 and 1, not much, but you can see 4 and 2. So think of it. Here's the concept. Once again, if this is a comma b, then the inverse will be b comma a. So let's go ahead and graph these now, right? 4 and negative 2. Over 4, down 2. All right? 1, negative 1. 1, negative 1. 0, 0. 1, 1. 4, 2. So if I were to graph this, I'm going to kind of do my best to graph it like this. Get that rounded. Now you can see that this function has now been inverted, and this is no longer a function. Okay? This is a relation. All right? You'd have to restrict the domain in order for it to be a function. All right? So, right here, what would you be allowed to graph, say in Desmos, where these functions would be invertible? So here's what you'd have to do. You'd have to restrict this function. So I'm going to go and close it real quick. All right, f of x equals x squared. And I'll make a little bracket here, but only where x is greater than or equal to 0. I'll go ahead and change that color to blue so you can see it. So that part, now I can invert. If we're only doing x greater than or equal to 0, then I can create the inverse, which would actually be, I'm going to put g of x equals the square root of x. And then if I zoom in, hopefully you guys can see that they are inverted. Now, here's the thing that you guys need to understand. If you have inverted a function, it will always reflect over y equals x. Every single time it will reflect over y equals x. So, no matter what it is, it will reflect across. So if I change this real quick, we're going to go ahead and draw this in real quick. Let me get my board. So let's go back. All right, so check this out. If I drew my parabola right here, which is still at 0, 0, 1, 1, 2, 4, and I did it on both sides, you can see that if I draw a line, y equals x, which is right here going through, you can see that it reflects across y equals x. So that's something you need to be aware of. Okay, go ahead and erase that. All right, so there is our graph. All right, so you're going to keep doing this over and over and over again. So remember, this did not pass the vertical line test. So if I had a vertical line that went through it, right here, it touches it more than one place. No matter where I touch it, it touches more than one place, except for right here. But if it touches any more than one place, it's only considered to be a relation. So let me go over the instructions one more time. All right. For each of the given parent functions, create a table of values containing at least 5 points on its graph. Use this table to create a table of values for its inverse relation. Graph the inverse relation of each parent function. Compare the characteristics of the parent function and its inverse. Is the inverse still a function? And the very first one, yes, the inverse was also a function. The second one, no, the inverse was not a function. But it would have been if and only if we restricted the domain. We'll talk more about that later. So for each of these, all I want you to do is exactly what I did. And if you need to use Desmos, you can use Desmos to help you guys graph the points. And that's it. Hope this video was helpful in you getting your assignment done.